So we're now going to talk about other concurrency and scheduler operators that are either in the Flux class or used in conjunction with the Flux class. And in particular, we're going to talk about the Schedulers'.parallel operator, which is designed to run computations in a parallel thread pool. So we saw an example of that just a moment ago when we were taking a look at the flat map concurrency idiom. Now we're going to talk about it in more detail. So the parallel operator hosts a fixed pool of single-threaded executor service-based workers. So it's a fixed number of threads, unlike, for example, the fork join pool, which can be made to grow or shrink. And it returns a scheduler that will basically do these computations, can do these computations in parallel in the pool. The size of the pool is obtained by a system property called Reactor Scheduler's default pool size. And as you can see here, it will fall back to the number of processors available to the runtime when the process starts to run, which is typically the number of cores, or the number of cores that the Java runtime environment thinks it knows about. And that's a little bit mysterious because typically on modern multi-core processors like my MacBook that I'm using here, it's got 8 hyper-threaded cores. The virtual machine thinks it's got 16 cores. So even though it's 8 cores, they're hyper-threaded, so it thinks there's 16. Anyway, it's whatever that value is set to. All right. This particular computation is optimized for non-blocking tasks due to its fixed size. If you recall, fixed size thread pools are really best for non-blocking computation-intensive things as opposed to I/O-intensive things. Here's an example of how we use this. We showed this earlier when we were talking about the flat map. And flat map, as you can see, is going to run each of these computations to multiply the big fractions by some constant in some thread in the parallel thread pool. Under the hood, the parallel operator uses daemon threads, which means that if for some reason the main thread were to terminate, like you fell off the end of main, all the threads that are in the parallel pool will also terminate as a consequence, assuming there are no other non-daemon threads still around. And that ensures that the app will shut down when everything's done. If that was not the case, your app would hang, and that would be confusing, and so that's why they do it that way. RxJava has a computation factory method that returns a scheduler that works the same way. So parallel in Project Reactor and computation in RxJava do the same sort of thing. They just have a different name for some God knows why reason. So that's the end of the quick overview of concurrency and scheduler operators. Again, seen an example of this. We'll talk about that more when we get to the case study.